Okay, so this is for function notation. So function notation just means that you're going to have f of x. Again, this is a review of what you did in middle school in Algebra 1. And then you have the f of x. That just tells me that, yes, this is a function for every x. There's only going to be one y. And then you have 3x plus 1. So it goes through and just kind of tells you. And this means f of x, and then it's just denoted 3x plus 1. So when we go through and doing this, you're going to solve by graphing. So what I like to use, again, we're going to look at this. So your function rule, when this is 0, so when my x value, my time is 0 right there. So when that is 0, when my x is 0, my y is also 0. So when x is 0, y is also 0. That real life context means this is the Denise's bicycle ride. So this is like her time. So her ride, her time is 0. And then the start is at the starting point. The start amount is 0. Okay, and then the next question, and this I'm just going to do different colors so you can kind of see my little dots. So now this time, this is when D is 7. So my time is 7. So I look, my time is 7. So then my value is at 2. So when my time is 7, so after 7 hours, the distance in miles is 2 miles. Now you realize that Denise is probably she's not riding her bike the whole entire time. She's probably like chatting with people or so forth. And now the next one is different. This time you're looking for the time. So you're looking for the time and you have the t value and you have this, you're finding your distance to be 6. So I look and I'm going to draw a line right here at 6. Well, Denise is never 6 miles away from her starting destination. So this is none. There's no solution. Okay? And so she is never 6 miles from her start. Okay, and then the next one. So this is where I go through and we're going to put this in and you're going to kind of look at this. And this time it's, I don't know if you can see pink. Maybe I'll do this color, red. So T is 4. So I'm going to draw a horizontal line when my distance is 4. And then I notice that I get that part that's in between there. So wait a second. This value right here is from 2 to 5. So this T, I'm just going to write 2 to 5. That's that distance that she is going to be from 2 to 5. That's going to be that particular distance. So that's going to be from, so hour 2 through hour 5. She is 4 miles from the start. So hour 2 to hour 5, she is 4 miles from her start. So she's taking a little stop break. Okay, and then the last question is, when does it hit at 0? So when is this going to be 0? So I draw my line again. I'm going to draw a horizontal line at 0. So when is it at 0? Well, it's the same thing we got up here. So we already know it's 0. And then, oh, wait a second. It happens at 0 again at 9 hours. So when T is 0 and when T is 9. So she went back home or whatever her starting. So she, at time 0, at 0 hours, and at 9 hours, she is 0 miles from the start. So again, it's at 0 hours, and again at 9 hours, she is 0 hours from the start. Okay, and then the last little section on this for function notation is going to be actually just going through and evaluating. So this last little page is page 3, is we're going to look at the evaluation piece of this. So we're going to look at evaluation. All right, so that evaluation piece, this time I'm going to highlight in different things because you have an F and then you have an E, and then you have a G. So you have an X, you have F, and then you have G. So if you're doing F, so everything that has an F in there, I'm going to highlight it one color, and I'm going to ignore this last one. So these two, I'm going to do X minus 3 and X plus 4. And then this next one right here, this is G. I'm going to highlight this one right here. I'm going to use that function G of X. And then that last one we're going to do later. All right, so for this next question, you have F of 2. So I'm plugging in. This tells me that X is equal to 2. So I'm going to plug 2 in. So 2 minus 3, 2 plus 4. 2 minus 3 is negative 1. 2 plus 4 is 6. Now, here's the deal. You can leave it as a fraction or you can change it as a decimal. I don't care. Personally, I'm a little lazy, so I would have left it as a fraction. But if you don't like fractions and they freak you out, go ahead, or you can write this as a decimal. So that decimal would be negative 0.1, and then it's 6 repeating. So either one of those two is your answer for function 5, or function f when x is 2. Okay, the next thing is we're going to do this again, and we're dealing with function f. This time I'm putting in negative 5. So I have negative 5 minus 3, and then negative 5 plus 4. So negative 5 minus 3. Negative 5 minus 3 is negative 8. And then negative 5 plus 4. Negative 5 plus 4 is going to be negative 1. Negative 8 divided by negative 1 ends up being positive 8. Okay, the last one we're doing on this is going to be function g. So now I'm plugging in 2 in for function g. I'm plugging x is going to equal negative 2. So we have negative 5 times negative 2 plus 7. And then negative 5 times negative 2 is positive 10. And then I'm going to go plus 7. And then 10 plus 7 ends up being 17. So this says when x is equal to negative 2, then the function, and we're calling this g, is 17. That's that real life meaning of what that function notation is. And that whole reason why we use function notation, is because it's a lot less writing to use. So x minus 2 is the same, that this whole thing, g of negative 2, is that whole thing of saying x minus 2, the function g, is 17. And then this last one we're going to do at a later date, but this is just to kind of help you. And this was all a review of everything that you have done in Algebra 1.